You wake before the sun because the fire has gone quiet. Not out. Not yet. Beneath a skin of gray ash, one coal is still glowing. Outside the shelter, wind drives powdered snow across a frozen plain. The temperature is far below freezing. Your breath hangs in front of you. Your fingers are stiff. Somewhere beyond the firelight, something large has been walking around the camp. There is no thermostat to argue with. No insulated wall, no electric blanket, no emergency weather alert politely informing you that going outside is a terrible idea. There is only that coal, so you crawl closer, feed it a twist of dry grass, and blow. If it catches, the night has been uncomfortable. If it doesn't, the next few hours may become a survival problem. This is how we often imagine winter in the Stone Age, a nightly contest between naked people and the weather, with everyone permanently one gust away from becoming an archaeological discovery. Frozen every night. Not exactly. Ancient humans did endure cold that could kill quickly. Some lived through glacial Europe. Others occupied Siberia, high mountains, and eventually Arctic landscapes. But they didn't survive because they were immune to winter. They survived by controlling the heat, wind, and moisture immediately around their bodies. And the real answer to the question, how did ancient humans survive winter, is much more interesting than they made a fire. It involves clothing that archaeology can barely see, carefully chosen caves, enormous appetites, seasonal intelligence, social obligations, and a tiny evolutionary witness that still lives in human clothing. It also involves one uncomfortable truth. Winter survival was never guaranteed. The people whose methods failed usually left us no story. Only the survivors passed their knowledge forward. First, we need to remove a misleading picture from our heads. There was no single ancient human, and there was no single Ice Age winter. Over hundreds of thousands of years, different human species lived in environments ranging from cool woodland to open tundra steppe. Temperatures shifted. Glaciers advanced and retreated. A place that was survivable in one period could become nearly empty in another. And cold wasn't even the whole problem. Winter meant fewer edible plants, shorter daylight, frozen water, migrating animals, dangerous travel, damp clothing, smoke-filled shelters, and the relentless need for fuel. A fire warms you only if you keep feeding it. Someone has to gather that fuel and keep it dry. Your central heating system is now a pile of sticks, and it expects someone to go outside. The body is also a difficult customer. Humans are tropical primates with unusually little body hair. We can generate heat by moving and shivering, reduce blood flow near the skin, and burn stored energy. But none of this makes us naturally comfortable on a frozen plain. Wind strips away the warm layer of air around the body. Wetness accelerates heat loss, exhaustion, and hunger make everything worse. So survival began before nightfall. It began with decisions. Where do you camp? Which side of the valley escapes the wind? Is the cave dry, or is it a stone refrigerator with a leaking ceiling? Can smoke escape? Where is the nearest fuel? Where will the herds move? How much daylight remains? The first winter technology may not have been an object at all. It may have been landscape knowledge. Even a crude windbreak changes the problem. A rock face can block prevailing wind and absorb sunlight during the day. A low shelter reduces the volume of air that must be warmed. Skins, brush, wood, bone, grass, and snow can all become building materials. Packed bodies add heat, too. Privacy in this arrangement is a luxury product that has not yet launched. This is why cavemen is such an unhelpful label. Caves were useful, but they were not universally available, automatically warm, or safely vacant. Other animals liked them as well. Bears and hyenas did not recognize human property law. Many ancient camps were in rock shelters or in the open, and the most important parts of those shelters were made from organic materials that usually rotted away. Archaeologists are therefore trying to reconstruct a vanished architecture from hearths, post holes, stone arrangements, animal bones, wear marks, and patterns in the dirt. The roof is gone, the bedding is gone. The wall covering is gone. What remains can look less like a home than the aftermath of a very disappointing picnic, but sometimes the floor plan survives. At Middle and Upper Paleolithic sites, the position of hearths and artifacts shows that people organized space. Hearth placement had to balance warmth, light, room to work, and smoke. Too far outside, and you lose heat. Too deep inside, and everyone spends the night inhaling the consequences. Airflow studies show how wind direction and shelter shape determined where smoke collected. At some sites, hearths could warm sleeping areas while smoke dispersed toward the entrance. People didn't need equations. They needed to remember which corner made their eyes burn and which one let them wake up breathing. That word memory matters. Because the most famous winter technology was powerful, but not simple. Fire has a deep and disputed prehistory. At Wonderwork Cave in South Africa, microscopic analysis identified burned plant material and bone deep inside the cave in deposits around 1 million years old. At Gesher Beno Yaakov, in present-day Israel, clusters of burned flint, seeds, and wood dating to about 790,000 years ago suggest repeated controlled fire use. Those discoveries are extraordinary, but they do not mean every human group from then onward could produce a flame on demand. Using fire, maintaining fire, and making fire are different achievements. A group might collect flame from a natural wildfire, carry embers, and keep them alive for days without knowing how to create a new spark. If that sounds improbable, remember that fire is not an object you own. It is a reaction you must continuously persuade not to stop. For a long time, archaeologists had very early evidence of burning but much later direct evidence of ignition technology. Then at Barnham in eastern England, researchers found a concentrated patch of reddened sediment, heat-shattered stone tools, and tiny fragments of pyrite in deposits more than 400,000 years old. Pyrite is not naturally present at the site, and when struck with flint it can produce sparks. The combination has been interpreted as the earliest direct archaeological evidence currently known for deliberate firemaking. That is the critical leap. A borrowed flame makes you dependent on luck. A manufactured flame turns knowledge into insurance. But even then, fire was not a glowing force field. An open hearth warms mainly through radiant heat. Your front can be warm while your back files a formal complaint. Fires consume fuel, throw sparks, produce smoke, and need attention. Someone may have had to wake and feed them, and in treeless glacial landscapes, wood could be scarce. Upper Paleolithic hearths sometimes contain large quantities of burned bone. Experiments show that fat-rich bone can contribute to a fire, although it behaves differently from wood, and the interpretation of archaeological deposits is complicated. The broader point is wonderfully practical. People used the fuels available to them. Warmth was not just discovered, it was managed. Fire also dried damp materials. It hardened or helped manufacture certain tools. It illuminated work after sunset. It discouraged some predators. If something large was pacing beyond the light, the flames could give it a reason to keep its distance. Fire also made frozen or tough food easier to process and many foods safer to eat. But warmth inside the shelter solved only part of the problem. The moment you left the hearth to hunt or gather fuel, you needed a way to keep that heat close to your body. That is where clothing enters the story. Stone survives. Leather usually does not. A beautifully fitted fur coat and a badly draped hide can both disappear without leaving so much as a button, especially when buttons have not been invented. So how can we know what people wore? We begin with tools. Scrapers carry wear and residues consistent with working hides. Bone awls and stone perforators could punch holes. Later, eyed needles made from bone or ivory show that people could sew pieces with precision. The earliest eyed needles appear in Eurasia during the Upper Paleolithic, with examples tens of thousands of years old. These tools made precise, close-fitting, and layered garments much easier to produce, reducing the gaps where wind could enter. The needle did not necessarily invent clothing, it upgraded it. You can make useful garments without an eyed needle. Hides can be wrapped, tied, pinned, or pierced with an awl and joined using sinew or leather thongs. Neanderthals lived in cold Eurasian environments long before the familiar Upper Paleolithic sewing kit became common. They processed hides, controlled fire, used shelters, and almost certainly covered their bodies in some way. Exactly how fitted or insulating their clothing was remains debated. Then there are the witnesses nobody invited. Lice. Human head lice live in hair. Human clothing lice live mainly in garments and lay their eggs there. Genetic studies have estimated when clothing lice diverged from head lice, using that split as an indirect clue for habitual clothing. One influential analysis placed the divergence at least around 83,000 years ago and possibly as early as 170,000 years ago among anatomically modern humans. This is not a receipt for the first coat. Genetic clocks carry uncertainty, and lice tell us nothing about sleeve length, tailoring, or whether clothing began for warmth, protection, display, or several reasons at once. But they reveal something archaeology rarely preserves. Clothing had become a stable habitat. Humans invented apparel, and another species immediately found a way to move in rent-free. By the later Ice Age, the toolkit becomes clearer. Fine needles suggest sewing. Awls suggest perforating. The remains of fur-bearing animals at some sites suggest skins selected for insulation, although an animal bone cannot prove exactly how its pelt was used. Clothing could include layered hides, leggings, capes, hoods, footwear, and bindings. The exact wardrobe is mostly lost, but the engineering principle is obvious. Trap still air close to the skin, block wind, stay dry, and cover the extremities. That last part is crucial. A fire warms a location. Clothing carries a microclimate with you. Once warm air could be trapped close to the body, the usable world expanded. People could hunt farther from camp, travel in colder hours, and occupy regions where an uncovered human body would be in immediate trouble. A fitted garment wasn't merely fashion. It let insulation travel with you. Ancient bodies contributed too, though we should be careful not to turn evolution into a superhero costume. Neanderthals were generally shorter and stockier than recent humans, with relatively shorter lower limbs. A compact body has less surface area in relation to its mass and therefore loses heat more slowly than a long, slender one. This is useful in cold environments. Useful does not mean sufficient. No skeletal proportion replaces dry insulation, calories, and shelter during a severe winter. Neanderthals were cold-adapted humans, not fantasy creatures strolling happily through blizzards in a fur loincloth. Their bodies reduced part of the cost. Their behavior paid the rest, and that cost was paid in food. Cold increases the energy needed to maintain body temperature, especially when people are active. Winter travel through snow is expensive. Hunting is expensive. Carrying wood is expensive. Processing hides is work. Even shivering is work performed by muscles without the satisfaction of going anywhere. Large animals supplied meat, fat, hides, sinew, bone, and sometimes fuel. But the most important word in winter nutrition may be fat. Very lean meat can provide protein while failing to supply enough energy on its own. The fattest parts of an animal, marrow and grease, could therefore be extremely valuable. Archaeologists find broken long bones at many sites, consistent with access to marrow, though the reason for every break must be judged carefully. Plants did not simply vanish from ancient diets, and human groups used whatever seasonal resources their environment offered. But in cold northern winters, reliable plant calories could become limited. Knowledge of animal migrations, body condition, and seasonal behavior was therefore not trivia. It was the difference between hunting an animal rich in stored energy and chasing a very athletic package of disappointment. But even excellent clothing couldn't help if the herds had moved and the valley held nothing to eat. Winter survival depended on knowing what would happen before the snow arrived. Hides had to be processed, fuel had to be gathered, tools had to be repaired. People could move toward sheltered valleys, coasts, rivers, forests, or places where animals gathered. Some camps were brief, others were revisited across generations. Researchers can sometimes estimate the season in which animals were killed by studying tooth growth, antlers, fetal remains, or the ages of prey. At some Middle Paleolithic sites, the evidence indicates seasonal hunting of animals such as reindeer. These groups weren't merely reacting to bad weather, they were predicting where food would be. If a region became too cold, dry, or empty, moving could be safer than remaining in one camp. But travel brought its own risks: unfamiliar ground, weaker social connections, and no guarantee that the next valley would be better. Sometimes people built more substantial places. On the plains of Eastern Europe, later Upper Paleolithic sites preserve striking circular arrangements of mammoth bones. At Mezyryk in present-day Ukraine, archaeologists uncovered structures built partly from skulls, jaws, tusks, and other large bones associated with hearths and work areas. Recent dating places the largest structure there at roughly 18,000 years ago, shortly after the coldest phase of the last glacial period. The exact reconstruction is debated. Bones may have formed a base or weighted framework covered with wood, hides, or bark. Not every mammoth bone ring was necessarily a house. Some sites may have served other purposes. But Mezyryk gives us a rare view of humans turning the largest available remains in their environment into architecture. It was not a cartoon cave. It was planned space inside and around such shelters. People made tools, processed animals, maintained fires, and lived close to one another. The shelter reduced wind coverings trapped warmer air. The hearth created a thermal center. Bedding would have insulated bodies from the ground because the earth beneath you can steal heat with astonishing efficiency. The result may not have been warm by modern standards. The achievement was not tropical comfort. It was keeping the body's core temperature stable until morning. And this is where the thumbnail question gets its honest answer. Were they frozen every night? Some were certainly cold. Ancient shelter was smoky, drafty, crowded, and vulnerable. Fires weakened before dawn. Clothing became wet or damaged. Fuel ran out. Children, injured people, and older adults faced greater risk. We should not replace the myth of helpless primitives with an equally silly fantasy in which every Ice Age camp was a cozy winter resort. But successful groups were not lying exposed on the snow. They combined defenses. A sheltered location reduced wind, a structure reduced air movement, bedding blocked the ground, clothing trapped heat, fire warmed, dried, lit, and cooked. Food fueled the body, shared labor kept the whole system operating. Remove one layer and the others work harder. Lose several at once and the situation turns dangerous. The deepest technology was therefore cooperation. A lone person must hunt, gather fuel, repair clothing, watch the fire, care for injuries, find water, and remain alert. A group can divide those tasks. One person carries embers while another carries food. Skilled hands repair a seam. Experienced hunters know where reindeer cross. Someone remembers the dry cave used years earlier. Someone stays awake when the fire begins to fade. Knowledge lived in relationships. A child did not have to rediscover hide preparation from first principles. A young hunter did not need to personally test every frozen river. Techniques could be demonstrated, corrected, and remembered in stories and routines. Long before written manuals, human survival depended on copying the person who had already made the dangerous mistake. Contacts beyond one camp may have provided mates, materials, information, or refuge when local resources failed. Archaeologists infer such connections from objects transported over long distances and from shared technologies. The exact relationships are rarely visible. We should not draw prehistoric friendship bracelets neatly across a map. But contact made people less dependent on a single valley. Fire also extended the working day. After dark, people could repair tools, process hides, prepare food, teach, and plan. We can't excavate those conversations. We can only see the hearths around which they became possible. Winter may even have intensified that social world. More hours in confined spaces meant more dependence on tolerance, rules, memory, and mutual care. The person beside you was not merely company, they were part of your life support system. This may be the oldest reason humans become extremely interested in whether everyone is doing their share of the firewood. Yet every solution carried a limit. Fire could burn shelters and fill caves with smoke. Close living helped warmth, but also allowed parasites and infection to spread. Heavy reliance on large game made people vulnerable when herds changed route or declined. Clothing required constant maintenance. A broken needle or torn seam could leave skin exposed to wind and moisture. Cold also preserved almost none of the individual tragedies. We find populations appearing in northern regions and later disappearing. We see gaps in occupation. We see technologies spread unevenly. Climate was probably one factor among many, including population size, ecology, competition, and chance. There is no single frozen night that explains the disappearance of a human species. This is especially important with Neanderthals. It is tempting to say they vanished because modern humans had better coats, better networks, or better planning. Each idea has evidence and objections. None is a complete verdict. Neanderthals endured repeated cold cycles for hundreds of thousands of years. Any explanation that portrays them as unable to handle winter ignores the scale of that achievement. So what can we honestly conclude? The evidence confirms that ancient humans used controlled fire, processed animal hides, occupied shelters, hunted and butchered animals, broke bones for resources such as marrow, organized activity around hearths, and eventually produced sophisticated sewing tools and substantial cold weather structures. The evidence strongly suggests that many groups used layered strategies, choosing favorable microclimates, carrying or creating fire, wearing insulating coverings, planning movement around seasons, and sharing labor and knowledge. It is possible that some early groups maintained naturally acquired fire long before they could reliably ignite it. It is possible that clothing was more complex much earlier than our surviving needles imply. It is possible that social alliances were as important during resource failure as any physical tool. What remains unknown is intensely personal. We do not know how warm a particular shelter felt at 3 in the morning. We do not know who woke to tend the hearth, how often garments failed, how people divided winter food, or which techniques were guarded, gifted, or forgotten. Organic technology has vanished and behavior does not fossilize cleanly, but the larger answer is clear. Ancient humans survived winter by refusing to face it as naked biology. They surrounded the body with layers of culture. Fire was stored summer. Clothing was portable shelter. A campsite was a machine built from landscape, fuel, hides, food, memory, and people. Now return to that first dark morning. The coal beneath the ash begins to brighten. The grass catches. A thin flame climbs into the kindling. Around you, other bodies stir beneath hides. Someone reaches for more fuel. Someone checks the weather beyond the entrance. Soon there will be food to divide, tools to repair, and another day of decisions. You are still cold. Of course you are. But you are not alone, not unprepared, and not frozen. The fire survives because you know what to do. And you survive because someone knew before you.